So like all good scientific work, Darwin and Wallace built their theory on observations and carefully collected data collected by both Darwin and Wallace and also other explorers. And there's a couple key observations that became the underpinnings for the theory of evolution by natural selection. The first one is that members of a population often vary greatly in their traits. The second one, species generally produce more offspring than the environment can support. So let's look at some examples of this. Here we've got a bunch of garden snails. They're all the same species. However, some are big, some are small, some are yellow, some are brown, and so there's variation within a species. Our second example here is a puffball, and this is producing thousands and thousands of spores, which will land on the ground and grow into new puffballs. Not every single one of these spores is going to survive. So certain individuals by chance are just going to land in just the right place in order to survive. I think both of these observations are fairly obvious to most of us when you say, oh, okay, that makes sense. But it was important that all these get outlined in order to build the theory of evolution by natural selection. The third observation is that traits are inherited from parents to offspring. And again, this is something that we know more about now with DNA and genetics, but at the time they didn't know what was inherited or how that might possibly work. Mendel hadn't done any of his work yet, and in The Origin of Species, Darwin actually referred to something called gemmules that might be passed on from parents to offspring. Number 4, resources are limited, so organisms have to compete, and because of that, many do not survive to adulthood, to reproduction. And finally, the geologists of Darwin's time were starting to establish that the Earth must be a lot older than 6,000 to 10,000 years old. The theory of uniformitarianism came out about this time, where geologists figured out that the same processes that would cause erosion in a dirt parking lot would also be the same process that could cause the Grand Canyon. And if that's the case, if water eroding dirt away can cause the Grand Canyon, the Earth must be much, much older than 10,000 years. The 10,000 year number comes from looking at the Bible and Genesis and who begat who. Current estimates are that the Earth is about 4.5 billion years old. So based on those observations, Darwin and Wallace came up with the following conclusions. Certain individuals are better adapted than others. Those individuals have more babies, and therefore their traits spread through the population over generations. This process could lead to organisms having a perfect fit for their environment and change a common ancestor into different species based on different environmental factors. This right here are the basics of the theory of evolution by natural selection. So let me give you an example of this. This is a praying mantid. Many of you guys maybe see these in your garden. The ones around here are usually about an inch long or so. And they've got these great big eyes, and they have these front legs that are grabbing. They're pretty aggressive predators. Then they have the thorax and the abdomen. There's over 2,000 different species of mantids on the planet, and here are two other species of mantids. So here this is a flower mantid, and here we have a stick mantid, same big eyes, front grabbing legs, thorax and abdomen. And notice, of course, they fit in perfectly in their environment. If they don't move, they're going to be very hard to see. This one I think is even more amazing. This is from Thailand, and this mantid, here are its eyes. This is the thorax. Here's the abdomen. Here's one leg, another leg, front leg, front leg. And so you can see it perfectly fits in. And Darwin and Wallace said, okay, way back in time, there was the ancestral mantid, and let's say it sort of looked like this one. And imagine that those mantids moved into various habitats, and one had more sticks and one had pink flowers. And so the baby mantids that were born with a little bit of pink coloring didn't get eaten as much as the ones that were green. And those babies had more babies that were a little bit more pink. And eventually, over hundreds of thousands of years, you end up with a mantid that looks like this. The mantids that were in this kind of habitat, if they were pink, they got eaten right away. If they were green, they got eaten right away. But if they were brown, they had more camouflage, they had more babies, and that got passed on to their offspring. So this is that process that could explain the diversity of mantids and ultimately the diversity of life on the planet. So modern evolutionary theory, this is Darwin and Wallace's ideas plus modern genetics. As I mentioned, Darwin and Wallace didn't know exactly what was passed on and how that worked. And so what I'm going to be teaching you in terms of modern evolutionary theory is going to include the genetic component as well as Darwin and Wallace's basic observations. This next video will give you a really elegant example of this idea of individuals adapting and having a perfect fit for their particular environment.